But thank you all so much for joining us. I know most of you on the call, but we appreciate you taking the time, especially on this week with Thanksgiving ahead of us. But really cool to kind of be a part of this ahead of the drives and ahead of kind of our US-based first drive and Q&A and materials going out there. So appreciate the couple of you on this call taking the time and being here with us. We're pleased to be joined by the chief engineer of Mirai, Tanaka-san, and he is open for questions. I just want to kind of reiterate that, some of the US-based questions that I'm sure we'll get, or that I'm sure you're thinking and have on your list based on infrastructure and power grid and some of the things that we're doing in the US would probably be better suited for our June 11th Q&A that we'll have all of our experts on that realm on that call and can really help answer that as far as what the US piece looks like. So Tanaka-san obviously can talk all things next generation Mirai and kind of globally our platform there. So kind of want to open it there, but if we don't have the answer to a specific question, I'll obviously follow up with you. I'll be taking note. But just want to thank you so much for being here and being a part of this. We're really excited about this vehicle, really excited to get Mirai out there. And I know everyone on this call will be driving it in 2 weeks' time. So can't wait to hear your thoughts and see what you think about this next generation Mirai. So with that, turn it over to Tanaka-san. Is there anything you'd like to open and say? And then we can kind of just open it up for questions. And for those on the call, you can fire away.
まず田中さんの方からオープニングのコメントとかありますかと。
はい。Hello, this is Tanaka. I'm Chief Engineer of Next Generation Mirai. すいません、日本語ですいません。
大丈夫です。
皆さんからですね、もうどんな質問でも結構です。車に関することだったら、どういう思いで開発したかだとか、もうそういうことも含めて、どんな質問でも受け付けますので、どしどしご質問ください。よろしくお願いします。
Yeah, and so thank you for coming today. He's really happy to be here. If you have any questions about the car, about why, the motive behind, he'd be happy to answer it. So please just go ahead and bombard him, and he's ready to take that all for you.
And real quick, let me hop in. Incredibly rude on my part. I did not introduce Toshi, who is our incredible translator and will be here.
It's okay.
Yeah, we go ahead and start firing away with questions.
Should you speak up?
Yeah. Go ahead, Russ.
Could you talk about, there's a lot more talk around fuel cells in the last year than there has been for a long time. What has happened in terms of cost and technology that have provided advancements to make this all possible in recent years?
今年に入ってからフュールセルの話題が特に多くなったと思うんですけれども、その中でコスト面でも技術面でも何が変わったんですか？
コスト面、技術面、この第2世代になってです、セカンドジェネレーションになって、量を10倍に増やすことができました、生産量を。そういうことができることによって、コストとしては、やっぱり生産コストは大幅に、半分以下に下がっています。
はい。So first off, in terms of cost, the second generation vehicle, the goal was to increase production capacity by tenfold, by 10 times. And so being able to achieve that, they've been able to make quite a lot more volume, thereby reducing the cost by half.
もちろんそのコストを半分以下にするというのは単に生産量が10倍にできただけではなくて、その10倍にするための設計のイノベーション、また部品パーツを減らすような設計のイノベーションがあったことに加えて、生産のイノベーションがあって成り立った話です。
And so it's not just about volume that they were able to reduce it less than half. It was also about multiple innovations in manufacturing, the reduction of parts, and so a lot of related factors that were that allowed the cost to be dropped. はい。あと技術面では何かありましたか？
技術面ではやはり部品パーツを減らした形で、性能がより上げれるという、例えばセル数は370セルから330セルに減ってますし、1セルあたりの、セパレーターの枚数も3枚から2枚に減っていますと、そういうようなことであっても性能を上げるというような、そういう、技術開発ができたので、そういうことも含めて、生産性の向上につながっています。
And then also from a technological aspect, as you mentioned, less parts. So for instance, in the tank, the cell count has been reduced from 370 down to 330. And then within each cell, there are separators that are separated by a thin metallic plate. And those separators have been reduced from 3 down to 2. So through these engineering developments, also, they were able to reduce costs and improve technology. はい。
I could go just one more question a little bit deeper. What were the main forces behind the reduction of the number of cells, being able to do that?
なぜそのセル数を減らしたんですか？どういう意図があったんですかと。
もちろんパワーは増やしているんですけども、やはりコンパクトかつ、ハイパワー、そして、低コストを実現するという、その、3つの観点で、最適な、設計をしたつもりです。
So the underlying motive behind that was, one was an increase in power. Number two, it had to be compact though and still produce the high power. And three, it had a low cost. So that combination, those three factors were the reason why the cell count was reduced.
Well, those are the effects of the cell count being reduced. I wondered what allowed it to be done. How did you get the increase in power, etc.
それは結果のことかもしれないですけど、じゃあ実際何をしてそのセル数を、下げてその実績が出せるようになったんですか？じゃあ具体的に。
なかなか細かい話になりますけど、触媒の反応性を上げたりだとかですね、あとはあれですね、電解質膜の厚さを薄くしてより、反応に対する抵抗だとか、電荷密度を上げるようなことをやっています。それはまた細部の細かい話は後に、あまりここに特化しても時間がかかると思いますので、細部の話はまた必要に応じて説明は発表しますけど、はい。
はい。So that becomes into really detailed things. Just some real, like 2 quick points would be increasing the response of the internal catalytic, I guess the converters, and then also not for exhaust or anything, but その触媒は、
触媒の反応性をより良くするっていう、
so improving response on that.
それとか電解質膜の膜の厚さを薄くすると、プロトンが通る抵抗だとかが減りますんで、いわゆる電流密度だとかが上がっていくので、今代表的なものを2つ挙げましたけど、そういうもののいろんなものの積み上げですね。
And so also the electrolyte membrane, I guess, and reducing the thickness on that allows the protons to pass quicker and reducing resistance. So if you're looking for very specific stuff, that's something that they can probably release a little bit later.
Yeah, that's perfect right there. Exactly.
それで一番聞きたいことだったらしいです。それが。はい、ありがとうございます。
Thank you. はい。
Hey, can we just speak up and ask a question?
Yeah, please go ahead, Mark.
Okay, the range has been increased quite a bit. I believe it's 400 miles now. How much of that increase in the range is due to the increased storage capacity for hydrogen?
約20、わかりました。約 20% ですね。伸ばしたんですけど、20% が水素の量のアップです。あと 10% は FC システム、それはハイブリッドシステムというか、いわゆる、電気をうまく使うという効率向上、SiC も、いわゆる半導体で使ってますんで、そういうことも含めて、効率向上を 10% やっています。
So right now, 20% would be due to the being able to handle more hydrogen, but also 10% is also another 10% is through system, through better electric management, including SiC. So 20% is from the tank, the extra hydrogen.
Thank you.
Hello, this is Alex. I was wondering if you could comment on the consumption of platinum. How much platinum does this use versus the previous generation fuel cell? Is it lower? And how does cold weather performance compare to previous generation?
はい。一つ目の質問が、プラチナの使用量、ファーストジェネレーションからセカンドジェネレーションに対して増えたのか減ったのかと。あと2個目が、関係、コールドウェザー、寒い天候の中での、パフォーマンスはどうなりましたかと。
はい。まず、プラチナの使用量は、ファーストジェネレーションがセカンドジェネレーションで減っています。
はい、
そして、寒い地域での使用性は、実はファーストジェネレーションからマイナス30度地域でも始動できるっていうのを確認してますので、そこについては細かなところでは使用性とか起動までの時間とかは短くはなってますけども、そこは大きく差がないと思っていただければ結構です。
So first one, for platinum usage between first generation and second generation, it's actually less use. And regarding cold weather performance, they had been able to confirm operation of the first generation vehicle in minus 30°C weather. And so the second generation, although it has slightly shorter startup times, the performance in cold weather is approximately the same.
Gotcha. And if I might ask one more question, what was the logic for formatting it as a sedan in this generation rather than a crossover like the Nexo?
なぜ今回セダンっていう形を取ったんですか？例えば CUV とかクロスオーバーになぜしなかったんですか？ネクソみたいな。
やはりですね、航続距離だとか走り、そういうところをしっかりとまず、FCV のシンボルとしての未来としてはそういうところをまず高めるのが必要だと思いました。もちろん、SUV にも、このシステムは展開することができるんですけども、まずボディタイプよりも、まずはその航続距離、そしてその走りの良さ、そちらをしっかりと高めたものを出すことが重要だというふうに考えました。
Yes, so the answer is yes, an SUV or a crossover could very well have been the platform for the first one, but his main priorities was to achieve first a long range for the vehicle, also high performance, because for FC vehicles, the Mirai is a symbol of the future, and Mirai means future. So in that sense, it had a mission statement that went beyond body types, and so that was his first priority, to get the long range and the performance done first, and that's why they chose sedan.
でセダンで成立するということはやはり、コンパクトで、ハイパフォーマンスを出す必要がありますので、そういう技術が確定されれば、大きな車 SUV にも展開することができますし、さらには、HD トラックのような大きなトラックにも例えばそれを複数、システムを積めばですね成り立ちますので、そういう意味からまずは、乗用、セダンで、ユニット開発を行ってそれを、そして数を出してですね、そしてそれを、トラックだとかまた違う車種に展開していくという、それがトヨタの、FCV を広げる、戦略になります。
And so the overall strategy for Toyota to proliferate and expand FC vehicle usage, one, they had to prove that they could put it into develop a compact high performance unit that would fit into a sedan first and succeed. Then once they get the volume out into the marketplace, then they could take the volume of those and start installing them into commercial vehicles like trucks and whatnot. and they could put multiple systems out there. But the first and foremost important thing was to get a compact unit into a sedan and prove it in the marketplace.
Is that partly because the cars just get a lot more visibility than in the media than trucks get?
I'm sorry, when you talk trucks, are you talking about commercial or crossover?
Yeah. It's starting out with sedans. The media pays more attention to that than they would pay attention to commercial trucks.
大型トラックよりも、例えばメディア的な注目度はセダンの方が高いから、それもあったんですかと。
やはりですね、車のかっこよさだと良さ、またこれぜひ皆さんにもロングリードなどで試乗していただきたいんですけども、今回見た目が大きく、魅力的に変わったということに加えまして、走りだとか静粛性、その辺もすごく良くなってますので、それはやはり、アピールできるポイントだと思います。かつ皆さんが、FCV の魅力、また水素というものの可能性をですね、十分感じていただけるものになっているというふうに、自負しています。
Yes, as you say, that is very true. The car, they're looking for a certain amount of a cool factor, the fact that it looks beautiful, the performance is increased. But also not only that, but quietness has been increased substantially as well, along with the performance. And the end result of that is that it becomes a very appealing car, which translate into FC vehicles are very appealing. They're very good. And then he wants more and more people to be able to experience the potential of a hydrogen-powered fuel energy source. And so that's sort of also the after effects that they're going after through a sedan use. Yes.
Awesome. Thank you.
Oops. Hi, Toshi. Can Tanaka-san elaborate on the move to rear-wheel drive as opposed to using front-wheel drive? Considering that's something we normally would see on like the Lexus division as opposed to sedan.
FF よりも FR を選んだ、理由、根拠、これはFR を利用するのはどちらかというとレクサスじゃないのかと、トヨタはちょっと FF 寄りだという印象を受けてたので、なぜですか？
はい、今回ですね、航続距離イコール、水素搭載量ですね、水素搭載量、そして、プロポーション、そして、走り、そして、居住性というかどれだけ室内空間が快適な空間ができるか、それは5名乗車も含めてですけども、そういう4要素において、ユニットレイアウト、いわゆるモーター、タンク、そして FC スタックのレイアウトをですね、いろんなパターンをプラットフォーム、フロント、駆動も含めていろんなパターンを考えました。そういう選択の結果、今回選んだリア駆動の水素タンクをいわゆる真ん中に通すというものが一番いいという結論を得まして、そのように選びました。したがって最初からリア駆動ありきで別に決めたわけではないです。
はい。So it wasn't that they chose FR rear-wheel drive first in the beginning. They had to have long range capacity. They had to have a high storage space for the hydrogen. They wanted good proportions of the vehicle. They wanted high performance and a lot of cabin space. And so when they went in and started trying to investigate the different kinds of scenarios for simulations, they had to take into account the unit layout of the FC system, which included the motors, the tanks, the stack. And so they actually went through every drivetrain configuration, every platform configuration, and trying to lay out the unit while maintaining those four factors I talked about, the capacity, the proportion, performance, and cabin space. And in the end, with the layout and the tanks in the middle, rear-wheel drive turned out to be the best setup.
それに加えましてですね、トヨタの FCV のシステムの考え方は、これはもうファーストジェネレーションから実は一緒なんですけども、タンクとかスタック以外の要素、 すなわちモーター、インバーター、セカンダリーバッテリーは、ハイブリッドでもすでに使っているものをうまく活用することで、少しでも、アフォーダブルに、車を成立させる、それは品質面も含めて、成立させるというところがトヨタの戦略ですので、そういう意味も含めて、その要素も当然プラットフォームの選択には、加わっています。
And another thing to add on to that is the overall strategy of Toyota when it comes to FC vehicle development is that everything other than the proprietary tanks and the stacks, things such as the electric motor, the inverter, and the battery, they want to use available components from other hybrid systems that Toyota already offers so that they can make the FC vehicle as affordable as possible and to get it out as efficiently as possible. So that's another reason that would affect final drivetrain layout and other future possible combinations.
Awesome, thank you.
All right, any more questions for Tanaka-san?
Yeah, I'll throw one more out. In general,
please,
pressurized hydrogen pretty much has to be in round cylindrical storage vessels. If that weren't the case, I would imagine that you could get even more hydrogen in there or more fuel in there because you would be able to have different shapes of the storage vessels. But as it is with high pressure, you need to have cylinders. Is that correct?
水素を保管する、タンクは、結論から言うと丸くないとその高圧に耐えられないっていうことを聞いたんですけれども、ただその形の実際の形状を変えられればもっと本当は理論上入れられるんですよね。でもやっぱり丸くないといけないんですかと。
そうです。丸くないとやっぱり四角とかになるとですね、当然可動部とかに応力集中が起こってしまいますので、高圧タンクの場合は基本は円筒形が基本です。
Yes, it's exactly how you say. For something as high pressure as that, if you use a square kind of vessel or a square shape, all the pressure will form and collect in the corners, and it would be uneven. So it has to be a round shape so that it disperses the pressure evenly.
Thank you.
As far as commonality goes, can you say which parts are shared with other hybrid or plug-in hybrid vehicles within the Toyota line?
コンポーネンツのシェアの話なんですけど、ハイブリッドシステムの、それをじゃあ具体的に、どのハイブリッドシステムのパーツを共有しているか教えてもらえますか。
はい。まずですね、ハイブリッドバッテリー、二次バッテリーは、3.5 リッターの V6 のハイブリッドの、二次バッテリーを使った、リチウムイオンバッテリーを使っています。
はい。So as far as the secondary battery from the system is from a 3.5 liter V6 hybrid, the lithium ion battery.
はい、そういう意味ではインバーターも一緒ですね。
And so is the inverter from the same system.
はい。で、モーターはもう一つ、小さい、FR のハイブリッドの MG2 を、コイルを使っています。そしてそれを、ケースを変えることによって、モーター単体のユニットに仕上げています。
And the motor is actually from one smaller unit, an FR rear-wheel drive unit. They've taken the MG2 motor, the coil from it, and put it in a new case that makes it work with the Mirai system.
I have a question.
Go ahead. I was going to say on the subject of the battery, what is the take on not putting a larger battery in some of the plug-in hybrid in hydrogen vehicles like this? I've noticed that pretty much everybody's hydrogen vehicle shares a lithium-ion battery with a hybrid counterpart, but the result is that you have relatively limited engine braking ability since regen can only fill the battery up about approximately 1 kilowatt hour. I'm assuming is what's available. I don't live at a particularly high elevation, but where I live, it definitely, you're relying completely on the friction brakes by the time you get down the hill. I would assume that would be a problem for wider adoption in areas like Colorado, where or the Tahoe area, where you're constantly going up and down steeper slopes.
はい、二次バッテリーの容量になってくるんですけど、なぜもっと大きいのにしないのかと。それは加速というよりも、そのエンジンブレーキ、要はバッテリーの容量で、その回生ブレーキの方が、そんなにできなくなってしまうんじゃないかと。バッテリー容量のリミットで。で、自分も、そういうちょっとこう、山道、そういうところ多いんですけど、やっぱり、回生ブレーキが多いところに住んでるので、やっぱりもうちょっと容量があった方がいいんじゃないですかって。なぜ小さいのにするんですか？
それはボリュームだとか、ボリュームってスペースですね、スペースだとか、当然最適な、ハイブリッドのものをそのまま使えるというメリットも含めて、今回このようなものを使んで、開発しました。ただ、回生ブレーキそのものは結果としては、ファーストジェネレーションよりも高めています。でただそれ以上にやはりバッテリーが満タンになるだとかそういうところについてはいわゆる ECB をうまく使うなどをしながらですね、いわゆるフィーリングの違和感がないような工夫はしています。
Okay. So one of the major ones in this particular application was a limitation of space, and also the ability to use the available shared components of the other hybrid systems as is to get it out. As far as regenerative braking, the performance of it has slightly increased over the first generation, and also through use of the ECV system, they made sure that the braking also feels very good without any awkwardness. So in that sense, that's the reason why the battery is the size it is. Does that answer your question, or sorry?
I guess sort of. The question would be, what is sort of the long-term, concept around this as hydrogen fuel cells get moved into larger vehicles where theoretically they would also be a good fit, say a hydrogen-powered pickup truck, which has already been rumored, obviously, but just larger vehicles in general. When downhill braking on long, steep grades, the battery would fill quite early, and you're left with just friction braking, which would leave you in a situation where your brakes are actually being called on more than they would be in a traditional internal combustion engine vehicle that would give you engine braking.
例えばじゃあその考え方として、じゃあ今後ピックアップトラック、トラックですとか乗用のトラックですとかに使った場合、彼たちがダウンヒルで走ってたら、回生ブレーキの場合ですぐバッテリーが満タンになってしまうじゃないですか。でそうするとそのまま坂がずっと続くとブレーキ、本当は回生してるはずがもう普通の通常の摩擦熱を出すブレーキングになってしまうので、通常よりもこのブレーキにも負担がかかってしまうと。全然もう得も何もないと。そういうもうちょっと今後大きな車に乗せた場合の考え方はどうなるんですか？
それはまたですね、実は大きな車に乗せた場合の、バッテリー容量、その二次バッテリーの容量っていうのは、このような、セダンタイプの、車とはだいぶ違った部分になると思います。
Yes, the thought process about about battery volume in larger vehicles, such as a pickup truck, the thinking would be different. So that is something that is obviously in mind.
例えば、これは実は乗用車でも一緒なんですけど、巡航には実はそんな大きなパワーはいらないんですが、やはり大きなトラックってやっぱり加速するときだとかですね、いわゆるトーイング的なパワーを使おうとすると、やはり、大きなパワーを長い時間必要になります。
Okay, so first off, for the thought process, and this also goes for passenger cars as well, but when you're cruising, there's no need for a lot of power for a prolonged extended amount of time. But for towing, you need lots of power for a long amount of time.
はい、そうですね。だから登院しているところだったら少しの坂道であったとしても、例えば、40秒とか50秒間大きなパワーが例えばいるっていうふうになるんで、それイコールどういうことかっていうと、やはり二次バッテリーを大きな容量のものを、必要とします。要はその瞬間的に例えば300キロワット、400キロワットのパワーがいるからといってそれだけの大きな燃料電池を積んでしまうとすごくやっぱりコスト的にも、システムの、いわゆる、 効率ですね。トータル効率的にもあまりよろしくないので、いかに燃料電池の量を適正化しながら、必要な時に必要なパワーを出すということを考えると、今度はそういう時に関しては二次バッテリーの今度は容量もそうですけど、パワーをしっかり出す必要がありますから、結果的にそれは容量も大きくなってきます。
So it's more of the relationship between the amount of power that the battery can supply with the actual volume of the battery. So you're always going to try to look for the best size that can give you the best power for the best amount of time for that particular application. If just throwing a bigger battery on the car, if you're only going to use the extra power for a couple seconds at a time, it increases costs and it puts unnecessary burden on the system itself. So if you're on a larger car, towing a car, and you're towing, and then you hit a hill, you're also going to need another 40 to 50 seconds of extra boosted power. So obviously then you will need an extra battery that can supply that extra boost. And so that would justify a larger size battery for that pickup truck probably application. So it is very application specific to trying to get that ideal balance between battery size, cost, and efficiency.
Hey, Alex, and I'll bring in real quick Jared Farnsworth from our research and development team here in the U.S., and he can add on to that.
Hi, Alex. You had a very good question regarding if you're coasting downhill and your battery SOC becomes full, how do you keep having that regen braking feel? And with, at least for the sedan, we were able to consume electrical power with other components. So there's no interruption to that braking feeling. So from the driver's perspective, there's no change. You'd still have that even if the battery SOC becomes full.
What's being used to consume the power? That seems unusual because I haven't seen that in the current generation Mirai, Clarity, or Nexo. When SOC is 100%, you get only friction braking.
So with the first generation Mirai, it has that capability as well, and it's consumed through the air compressor and other components. And the total power consumed is the same as the normal D-range braking. And
okay.
that technology has been carried over for Gen 2.
Got it.
I'll throw out another one if I may. This car, I believe, is 50-50 weight balance. Is this going to be a sporty sports car?
車重のバランスが50-50だということですが、これはスポーツカーになるんですか？
いや、スポーツカーというよりはですね、やはりある意味スポーティーに走るということも含めて、リア駆動の車においては50対50のバランスというのはすごくやっぱりハンドリングを良くする上において非常に良いという、理論的に良いというウェイトなので、そういう意味においてはスポーツカーでなくてもやはり気持ちよくワインディングを走っていただくとかという上においてはすごくウェイトバランスがいいということはコーナリングの性能も高くなりますんで、そういう意味からそこはすごくこだわって成立させました。
Because handling and performance was one of the major priorities of saying FC vehicles can accomplish this, it's not per se a sports car, but is very capable of sporty performance. And once again, because handling was one of the priorities for development, it had to feel good also on winding roads and just really show a high level of cornering ability. And so that's why, and obviously the 50-50 weight distribution is good for that. So.
Any other questions?
As long as we got them on the phone or the Zoom here, might as well ask, what are the tires on this? The Mirai and the Prius had tires that broke away very nicely and were a lot of fun as a result, if not offering ultimate grip. Are these tires going to be aimed at better grip?
タイヤは今回何を装備してるんですかと。前のプリウスとかああいうのはすぐスピンして、とても楽しかったんですけど、今回はもうちょっとトラクションのあるタイヤを選択するんですか？
そういう意味ではですね、ホイールは19インチと20インチ、2種類あります。で、そういう意味においては19インチはどちらかというと、 乗り心地と、いわゆる転がり抵抗というか燃費性能と、あとは、静粛性ですね。ハンドリング、ごめんなさい、ハンドリング、乗り心地、燃費性能、それの、バランスのいいのが19インチ。20インチはより、多分今の方は、運転の、すごくスポーティーな運転が好きそうな方ですから、そういう意味では、グリップ性能だとかは20インチはすごくいいものを使っています。
So the Mirai will be offered in 19 and 20 inches tire configurations. The 19s will be a nice balance of quietness, handling, fuel economy, and ride comfort. But he believes that when you're asking a question, you like to do sporty driving. So you'd probably want to go with the 20s that offer a much higher level of grip, and that will be geared towards performance.
そしてですね、ちょっとタイヤの質問があったので、タイヤについてもちょっとコメントをせっかくなのでします。タイヤがですね、今回実は19、20インチというホイールの大きさの話をしましたが、タイヤ径が実は約40ミリあります。タイヤの直径が。
Okay. Hi. So right now, just because we were on the topic of tires, he just wanted to add one more comment. The tires are obviously available in 19 and 20 inch, has a full diameter of 740 millimeters.
はい。このタイヤはファーストジェネレーションよりは実は2ランク以上大きなタイヤになっています。
And so these tires are actually 2 ranks larger than the first generation tire size.
これは実はこの未来がですね、かっこよく見せるために重要だということに加えまして、もちろんタイヤが大きいとかっこよく見えます。
So, obviously one of the mission statements for the Mirai was to look good, and so obviously larger tires look good.
加えましてですね、やはり水素タンクを床下に積んでますので、そのタイヤの半径が大きいということは、キャビンのスペースをしっかり確保した上でタンクの径を大きくできます。これわかります？
By changing to larger tires, they can put in larger tanks into the vehicle underneath the floor while maintaining cabin space. はい。
なのでそういう意味からも、見た目だけという要素よりはまずは水素をたくさん積んで、良いキャビンスペースを確保するために、今回の未来においてはこのを大きくする必要がありました。
So there was actually a necessity to increase tire size so that they could fit larger tanks into the body while still maintaining ample cabin space. And so that was another reason why the tires were enlarged over the first generation.
どうもありがとう。
Thank you.
All right. Any other questions?
Hey, I'll keep asking questions. We got this chief engineer here. That's a good opportunity. How much headroom is in the back seats? Is it like a coupe or more like a sedan? How would you describe that?
リアのヘッドルーム、頭のスペースはどれくらいあるんですかと。クーペみたいなんですけど、どう説明しますか？
そういう意味では、決して、広くはないです。が、
So, it's probably not a huge amount of space. It's not very ample, but
決して広くはないですが、見た目はファーストジェネレーションよりセカンドジェネレーションの方がスリークになってますけども、ファーストジェネレーションと同等の、ヘッドクリアランスはあります。
So if you compare sort of the profiles of the first generation versus the second, the rear side looks very sleek and it looks lower, but they've managed to save the same amount of headroom as the first generation.
かつファーストジェネレーションはフロント席の床下に実はセカンドシートの、いわゆるお客さんの足が入らなかったんですね。
So actually, the
あ、
rear
はい。
seat passengers could not put their feet under the front seat on the first generation.
それが今回はスタックの搭載値も、工夫したことで入りますので、そういう意味では、後席の、ユーザビリティっていうか、ビリティは、ファーストジェネレーションよりもはるかに向上しています。シートのホールド性だとか、シートの座り心地も含めて、ファーストジェネレーションよりもセカンドジェネレーションの方がかなり良くなっていると思います。
And due to their efforts in relocating the stack system, now on the rear seats, they're much more comfortable. They're much more usable. You can fit your feet underneath the front seat. And also, actually, all the seats, hold and comfort have been improved significantly over the first generation.
Thank you.
I had a quick question. I'll take over for you for a sec, Mark. I noticed that the acceleration figures given out in the spec sheet, 9.2 seconds, 0 to 62, that's pretty close to what the outgoing vehicle was. So I guess my question is, even though the new one makes more power, why is the acceleration number roughly the same as the old vehicle? And do you think that it needs to be faster to be a better driving vehicle?
加速になるんですけど、
はい。
ファーストジェネレーションとほぼ同じ062マイルが 9.2 秒だと。でも今回もっとパワー出てるのに、なんで同じようなパフォーマンスなんですかと。で、やっぱりそのドライバーハイパフォーマンスの印象を出すのにはやっぱりもうちょっと早くしなきゃいけないと思いませんか。
そういう意味ではごめんなさい。実は、060マイルで行くとですね、9秒は切ってます。9秒は切ってます。0100が9秒やからね。060マイルは9秒切ってますし、ファーストジェネレーションよりも約 10%、速くはなってます。060マイルにおいては。で、さらに、まずそこまで行きましょう。
Hi. So just one clarification also, maybe if we're wrong, Zach can jump into, but the 0 to 60 time that he has would be under 9 seconds. And also the vehicle is 10% faster than the first generation. はい、どうぞ。
そして、加速時のやっぱり車両姿勢、いわゆるピッチっていうんですけど、車両姿勢が加速時に、あまり大きな変化がないように、車両姿勢をコントロールしていますので、そういう意味においては、またぜひロングリードで確認していただきたいんですが、タイム以上に、ファーストジェネレーションよりも、2ランクぐらい速くなっているイメージがあると思います。
はい。And this is one thing that actually he'd love for you to check out on your own when you actually get a chance to drive it, is that they've spent a lot of time controlling the pitch of the vehicle during acceleration, so that and controlling and maintaining it so that the car feels almost two times fast, two levels faster than it really is, because you're maintaining that pitch control. So that's something he'd really like you to experience. It feels faster than it really is.
Cool. Thank you.
あとですね、中間加速、特にその中間加速っていうのが、どうだ、60マイル、30から60マイルの加速タイムなんかは、2.5 リ、0-100キロの、060マイルの加速タイムが、このセカンドジェネレーションよりも速い、ハイブリッドと比べても、2割以上、30、60マイルなんかは速いので、そういう意味からすると、実際に運転していただくと、決して非力な感じはしないと思います。もちろん、テスラなんかと比べる、テスラというかEV と比べると、それほど爆発的ではないですけど、十分速さは感じていただけると思います。
Yes. And so obviously it doesn't have the explosive acceleration, let's say compared to a BV, Tesla or something like that. But what it does have is, let's say for a comparable, let's say 2.5 liter class and up hybrid car that has a similar 0 to 60 time, the mid-range acceleration from, let's say, to about 30 to 60 miles an hour, that is about 20% better. So it will once again, the perception of the feeling of the acceleration is much more pronounced on the second generation. So that's another thing he'd really like you to try and experience.
Will do. Thank you.
All right. Anything else? Going once, going twice. All right. Well, thank you all so much for being here. We appreciate you participating and interacting with Tanaka-san. Tanaka-san, thank you so much for being here. We really, really appreciate you. And everyone on the call, I know you'll be driving the vehicle in just a couple weeks, and we'll have follow-up materials and US spec and product information, press release that we'll be sharing December 7th, and then Friday, December 11th, we'll have another Q&A with kind of the US-based team that can speak kind of to a broader spectrum, not only with the vehicle, but also with infrastructure and kind of US-based questions. So look forward to seeing you all there. And I know you have my email. Reach out if you have any follow-up questions or you need anything at all. I'm here, but appreciate you so much. And if we don't speak, have a great Thanksgiving, and thank you so much for being here.
あと最後に一言いいですか?
He'd like to add just one last thing. One last
please,
comment.
Please, Tanaka-san. Yes, please.
今日はどうも QA セッションに参加ありがとうございました。私ですね、まだ皆さん車に乗ってらっしゃらない中でのコメントなので、なかなか分かりにくいかと思いますけども、今回のこのセカンドジェネレーション未来は、ハイドロジェンソサイティ、水素社会をなんとか開くきっかけになりたいという思いで、トヨタが持てる技術のすべてを注ぎ込んで、まさにフルスイングで開発をした車です。そういう意味においては、
first off, thank you so much. どうぞ。そこで続けてください。はい。So first off, thank you so much for joining us for this QA session. Although many of you haven't driven the car yet, this vehicle, this second generation vehicle, is his passion and dream of creating a hydrogen society, and it incorporates all of the technology that Toyota currently possesses, and this symbolizes a full swing from the engineering side of his company. はい、どうぞ。
はい、実は私はファーストジェネレーションのチームフエンジニアでもあるんですけども、ファーストジェネレーションはある意味やはり、フューエルセルビークル未来、要は燃料電池の未来であることを例えばデザインしただとか、そこが、ある意味すごい売りというか、そこを強調したんですが、今回は、走りの良さだとか静粛性、またハンドリング、そしてプロポーション、見た目ですね、そういうところ、車本来のところを皆さんに見ていただくという思いで、デザイン、また設計した車です。
And so, because he was Tanaka-san was also the chief engineer of the first generation vehicle of the Mirai. Back then, the mission in the statement was, "Here we've developed the fuel cell vehicle (FCV). Here it is." But for the second one, now he wants to go deeper and basically get the design, the driving performance, the quietness, the handling, and really get the proportions and get those secondary new values and those new message statements out to the people.
はい。そういう意味ではですね。燃料電池であることは、ある意味、魅力なんですが、それが全てではなくて、魅力のうちの一つであります。
Yes, and so the fuel cell technology itself is very appealing, but that's not everything about this particular project.
はい。ですので、皆さんが車をブラインドで見ていただいて、乗っていただいて、そして、感じていただいて、その結果すごくいい車だと言っていただける車を目指して開発しました。ですので決してその FCB が前提条件ということではありません。選んでいただける上の。
So the main point of this vehicle is he